Electronic Project 5, making monostable timer using 20-cent IC. This IC chip is well-known 555, and 555 is the timing device, very cheap. We use this chip to make a timing control circuit. In this video, we show you the complete process. This is timing we're talking about is very slow timing domain, like a millisecond to several seconds, like traffic signal, car winker is a perfect application to make. Digital circuit is too fast. Typically, digital circuit is microsecond and nanosecond, and they are not suitable for making like traffic signals and those stuff, because you have to count down so many numbers to get even 1 second. The timing, how do we generate the timing? Basically, we use capacitor charging time. Okay, so the capacitor C is charged up through this resistor R. So when it's charged up, the voltage V become from 0, gradually increase and reach to eventually E, and this may take a long time. So we cut off at 1/3. Okay, when 1/3 level is reached, then we consider it's charged and release. The capacitor is discharged, and when discharged, the same process is exponential curve. It's go long way, so 1/3 we consider is discharged. Then the charging process start again. So take this kind of circuit output, make a digital circuit, then we have a time TR and TD. Okay, so charging, discharging, that's the key of the timing control. Set discharging point at 2/3, which is here. Okay, this is the 2/3. This height is 2/3, and the remaining 1/3. Remaining 1/3 is not appropriate to use for timing, because it's a lot of error in time when it's exponential function get close to the maximum number. So the V is E minus Ri. I is charging. I equals C dV dt. And this differential equations, the V is given by E 1 minus E to the negative T over RC. RC is going to be the time constant. And if you solve this one, the TD this time is given by this RC log 3, and the log 3 is 1.1, so it's 1.1 RC. So choosing a proper RC component, 1.1 times is going to be TD. So this is the time. So when it starts charging, this voltage start going up, and it's reached to the 2/3 of the voltage E, then that's the we consider it charged up. And we can also use this TR, this 1/3, which is RC 0.41 RC. Okay, so how we make this kind of circuit? It's already made. That's the IC chip 555 timer. 555 timer is made of comparator. Internally has the power to ground divided into 3 voltage, and this is a 2/3 as a comparator. So this is a threshold signal you set. Then we can give a signal R. This is a RS latch, and I explained to you about what the RS latch is. The RS latch has a reset and a trigger. Give a signal set and reset. Then when this output become high, then this device turn on, and this point is going to be short circuit to the ground. So if you have this charging device here, you connect it here, we start discharging the current flow this way to the ground. So this V becomes 0. So V goes up to 2/3 of E. Then suddenly this RS latch kick in, and this transistor turn on and discharge to 0. So that's what this action is. The voltage go up to 2/3 of E, and suddenly this discharge happen. The voltage across the capacitor becomes 0. Okay, so this is IC chip. So what is RS latch? RS latch is made of 2 NAND gate, or you can make it by 2 or NOR gate. Basically, RS latch operate by set and the reset, and we say this is the output, but output negative is going to be when reset signal is active low. When this goes low, both become high. So both become high. If this is out, we should say 2 instead of complement, right? The both become so reset has to be high. This signal has to be high in order to operate. And when set and reset is low, then output is, we don't know, because if low, this high, it could be low and this could be high. So the either 0 or 1. Here is 0 or 1 or 0. So how do we know? What's happened is you give a signal set 1, right? Then out becomes 0, out to become 1. So this is a set action, and you bring this S0. So you set, and after that reset is this state. Then it's flip. The result is flipped. Okay. And when both are high, then actually unknown state, but same as reset. This guy, active low reset. This is same as reset. So RS latch operate here. Either you set it, this is set, or reset, the flip the output. Okay, or both are 0. That means it's retain the last result. So if last result is this, then this is gonna be 0, 1. This is 0, 1. If last result 1, 0, so it's a memory. So latch is a memory. It's memorized last state, logic state. Okay, and how to change the logic state is set or reset. Okay, so this is 1 bit of memory chip actually. This is 555 IC chip. So this is discharge point, means it start discharging. It short circuit to the ground. Okay, so this is a C. Input is a trigger. Okay, and this is the active low, means when this goes low, trigger is on and come back. So this is connected to set of the latch. Okay, and threshold is this voltage V, the charged voltage to the capacitor, and the capacitor charged through this. So the timing of charging is 1.1 RAC. Okay, and discharge, this point is discharged as soon as it's reached to the 2/3 of the voltage. Okay, and RS reset is disabled by tying permanently high, and this is an internal threshold. We put the capacitor to make it stable from the noise. This analog circuit, the noise may get in here, so put like 0.1 microfarad or 1 microfarad, the small one, but the high speed, I think it's capacitor type is high frequency responding capacitor, and this is the digital output. So when this goes to 2/3, V goes to 2/3 of E, then output drop because it's the discharge, this point of discharge. Okay, so single trigger cause single charging, so you get the 1 digital pulse, single shot pulse generator. That's a monostable operation. Okay, and we're going to make a breadboard using this IC chip and confirm the operation. Now, what we can do is, what's happening if we discharge here instead of here? Okay, so now the discharge is going to be discharged through this resistor R2, R1. So it doesn't drop suddenly like this, it's discharged like that. So there will be extended time. Okay, so the voltage, output voltage looks like this. Now using this, we can make a stable operation. A stable operation is trigger coming from the output. That means when trigger goes low, then this drop by discharge, then this trigger again. Okay, but having this trailing edge, trigger will be here. Okay, so having RA, RB, and C, we connect trigger input from this output, so we continuously trigger. Okay, so when discharge, it trigger again, discharge, trigger again. So by doing this, it's oscillate. So the output is going to be like this is going to be output logic signal. Okay, so we can make a oscillation with a crystal RC constant oscillator, and we can use this as a slow clock for controlling various things, like, as I said, traffic signal or wiper of the car or whatever. This is the idea of circuit, and it's very cheap. It's a 555. It's like 20 cents IC chip, and we can make this one. Okay, so let's see the breadboard. Okay, so this is the breadboard. IC chip 555 is in the center, and this is the push switch to generate the negative in the pulse trigger, right? And this is the output monitor LED. When output goes high, it's light up. And here's a resistor 10K plus variable resistor in series connected to the capacitor is 100 microfarad. There's 10K and plus another 10K, 20K. So it's going to be like a 2 to 3 seconds unless we reduce variable resistor. Okay, that's RC constant. So turn on the switch. Okay, initially output is 0, right? So we press, give a negative impulse, the 1 second, and we change this all the way back here, 1, 2, about 2 to 3 seconds. So variable resistor can change the timing, 1, 2, getting shorter. When you change to the smallest value, 1 second. Okay, so this is like a 0 ohm, it's 10K, and 100 ohm, it's going to be like 1 second. So the maximum is 2 seconds, 1, 2, 2.5, about 2 seconds, 1 and 2. Okay, well, about 5 kilo ohm, 1, 2, so slightly less than 2 seconds, right? So we can control the RC constant, the timing of single pulse generated. Okay, now we do something more interesting. So what we do is we move this guy into this. Okay, this is the discharge. We discharge between resistor. So the discharge goes through this resistor. So instead of discharging suddenly, it's going to gradual discharge. Okay, so let's see what's happened. A little bit longer, right? Let's see. 1, increase resistor to discharge. 1, 2, 3. Okay, now what makes the difference is discharge will have a trailing edge. Now trailing edge is gradually discharge in this configuration. So what we do is we let it oscillate. Okay, now what we do is we are going to make a stable. So it's going to oscillate. Now we pull out this impulse input and the feedback from this discharge. So what's happened? Okay, so it's
feedback. The impulse is generated by the output, and output, the impulse is gonna go through the circle again. So it's going to go through, and the frequency is going to be, see, this trailing edge is going to be shorter, so duty cycle increase. And here you go, this is like a 50-50 duty cycle, 10K and 10K right now, so it's just about right. Okay, so that's what it is. I hope you get this small power supply and the breadboard, and the 555, it's very cheap, IC chip, and put the parts together. Then you can make it work exactly as the circuit diagram indicate.